Great. We've got a few people here already on. We've got a couple of minutes on the clock here. This is Pete Williams with Pints with Pete for July 2014. This is called the Voyage into Valves. And we have a special guest here, Mr. Ron Bleckley of Sporland Valves, division of Parker-Hannifin. And this is a great presentation, and I think you guys are going to really learn a lot here. Again, the format, as always, is we leave the phones on mute. If you have a question, type it in. Please remember the person that asked the best question wins a six-pack of the Missouri Microbrew. Unico employees are not eligible for this, unfortunately. For the Unico employees that are on here, we give this to our customers. So let's start this slideshow up. And guys, as I say, this is a kind of a neat slideshow. The graphics on it, I wish I could come up with graphics like this. And Ron is going to demystify the expansion valve. A lot of people, especially before 13's here, the expansion valve was the mysterious black box. Anything went wrong. Obviously, it was the expansion valve that was bad. So I think we've all learned that's not the case anymore. And let's see what we have on the time. We still have a couple of minutes by my clock before it's 3. So we're going to start this up precisely at 3. And we're going to save this on our website. And also I'm going to have Ron give you the contact information for Sporland. Sporland has a great training class. I think if we have any of our folks listening in from Kentucky, you qualify for continuing education credits. Is that right, Ron?
Yes, most likely.
Okay, very good, very good. So we've got about half the people that were signed up already on, and we'll hope to see more people come on. And it's 3 o'clock straight up by my clock, so I'm going to turn this over to Ron and maybe learn a few things.
All right, thanks, Pete. Like I said, this is a Pints with Pete, Voyage into Valves, and although there are numerous publications on the theory and operation of expansion valves, some technicians seem to fall into a black hole whenever confronted with a system using a TEV. It doesn't take a rocket scientist to troubleshoot a system using a TEV as a metering device. Today we will cover the basic operations of a TEV, installation tips, and some troubleshooting guides. The function of a thermostatic expansion valve is to maximize the amount of liquid refrigerant in the evaporator coil under all load conditions, and it does this by controlling superheat. So that means it's not a temperature control device, it's not a suction pressure control device, and it's not a humidity control device. It only controls superheat. When refrigerant is present in both liquid and vapor forms, it is considered a saturated liquid or a saturated vapor. The saturation temperature is the temperature that the fluid is during the phase change from liquid to vapor or from vapor to liquid. Saturation occurs in both the condenser and then as it changes from state from a vapor to a liquid, and the evaporator as it changes from state from a liquid back to a vapor. At saturation, the liquid has experienced its maximum temperature for that pressure, and the vapor has experienced its minimum temperature for that pressure. However, both liquid and vapor are at the same temperature for a given pressure when saturation occurs. These pressure-temperature relationships are plotted in your PT charts that are referenced every day by you guys. Superheat always refers to a vapor, and subcooling always refers to a liquid below its saturation temperature. Notice the point of complete vaporization. We typically want to have that somewhere at the last bin to the outlet of the evaporator. And it's that point of complete vaporization is when the saturated liquid has become 100% vapor. And superheat is nothing more than the difference between the actual temperature and the saturated vapor temperature. Since the TV only controls superheat, it is very important that you understand how to take a good superheat reading. Use your temperature probe to take a good temperature reading. Use your manifold gauge to get a good pressure reading. Then use your PT chart or the Sporland's Chillmaster PT app on your smartphone to convert this pressure to a temperature. You find the difference between the two, and that's your superheat. In this case, we're looking at 54 degrees at the temperature at the bulb, and then this 130.7 psi. Converted to temperature then would be 45 degrees, so you have a difference of 9 degrees, so that's your operating superheat. The lowest amount of superheat you can have is 0. You cannot have a negative superheat, so if you come up with a negative number, you've done your math wrong. 0 degrees superheat means you have 100% liquid at the bulb or beyond, And if you have at least 1 degree superheat, it means you're not in a flooded condition. Let's begin by talking how the expansion valve works. We'll start with the 3 fundamental pressures that control the valve. One is the bulb pressure. The constituents in the bulb are designed to provide the opening force of the TEV by mimicking the pressure-temperature relationship of the refrigerant being used in the system. In most cases for Unico, this is going to be either R410A or R22. The bulb pressure pushes down on top of the diaphragm, flexing it so it can push against the buffer plate, pushing the push rods to push the pin out of the port and opening the valve. Number 2, evaporator pressure. That's the pressure comes from the external equalizer connection from the suction line at the outlet of the evaporator. This pressure is applied under the diaphragm and helps close the valve. And then there's superheat spring pressure. This is the amount of pressure that the spring has been set to maintain the desired superheat. It acts on the underside of the diaphragm as well as and works with the evaporator pressure to assist in closing the valve. In most cases, Unico supplies a non-adjustable TEV, so this spring pressure is factory set by Sporlan at the specifications given by Unico. And whether you're using an adjustable or non-adjustable version of valve, the superheat spring pressure is a fixed pressure. Once it's adjusted, it stays there, it's fixed. The bulb pressure and the evaporator pressures change as the load changes, and that's how the valve either opens or closes. Pictured here are a couple common TEVs that Unico uses. Although I do have pictures with solder connections, they usually use a chat lift connection. The valve on the left is a non-adjustable version. You can notice the flat bottom and the 2-piece construction. It only has the valve body and the bottom cap. The valve on the right is adjustable. It has a 3-piece construction. The valve body, the bottom cap, and the adjustment seal cap. Underneath that seal cap is the adjustment stem. Going through the nomenclature, the C in this case means it has a check valve. It has an internal check valve. It will meter in the forward direction and that path through the check valve and reverse flow. It's designed for split system heat pumps. It can be used in air conditioning systems as well, since the check valve just said idle. The omission of the letter C indicates that it doesn't have the check valve. Next is the BBI. It's the body type. The first B is indicating it's a balance-ported version. So it's the balance-ported BI valve. The Z is a refrigerant code. In this case, Z equals 410A, and R22 would be a letter V like in Victor.
It's a very important thing to check, guys. I know we pretty much made a 100% switch to 410A, but we were asked this very often whether they had a 410A or a 22 valve. So there's your answer right there.
So then, so Z is 410A, then V is R22. The 2 in this case is indicating it's a 2-ton valve. We always tell you the tonnage of our valve, not the BTUs rating. It's an actual tonnage. And then the GA is our thermostatic element used for heat pumps and air conditioning applications. And then some valves will have a bleed port and indicated the letter B at the end, and then a number like in our example is B15. So this indicates it has a 15% bleed. This allows the system to bleed back through the valve, bypassing the pin port to equalize the pressure during the off-fill, very much like a cap tube system. The bleed port can be a drilled passageway through the valve body, or it could be a machined notch in the seat that allows a controlled amount of seat leakage. This 15% bleed also increases the capacity by 15%, since it is a continuous passageway with no way to close it off. The principal parts of any TEV, the diaphragm, capillary tubing, and bulb all can make up the thermostatic element. You have a seat, whether it's a drilled passageway or a screwed-in seat. Push rods, sometimes 2 push rods. In this case, this is a balance port. It has a single push rod, and the push rod and the pin are a combination. You have a spring, superheat spring, spring guide, and if it's adjustable, you have an adjustment stem. Here's a cutaway view of the internal parts for a BBI valve, or a CBBI valve, sorry, that is non-adjustable. So the thermostatic element is made up of the lock ring. It's made up of the casing, the diaphragm, the bulb, and the capillary tube that attaches to. So all that is the thermostatic element. And then you have the drill. This case is the drill hole for a port. Then you have your push rod and pin combination. You have your superheat spring, the spring guide, and over here is the little poppet for the check valve. So in the number of flow, the refrigerator will come from left to right. It'll push the poppet closed, it'll force it through the pin and port, and then the expansion will occur, feeding the evaporator. Reverse flow, the liquid will come in from the right towards the left. It'll take the path of least resistance, so it won't go through the pin and port, because instead it's going to open up that poppet and allow free flow through the check valve. Sporlan produces internal and external equalized TEVs. The internal equalized valve has a drilled passageway on the outlet side of the valve to the underside of the diaphragm. It senses the low side pressure at this point, and any kind of additional pressure loss through the coil or distributor, if it's one that's being used, will not be sensed. The external equalized valve has an extra connection that must be installed on the suction line downstream of the bulb location, and this will allow the valve to sense the actual true low side pressure at the suction line. Unico uses only the external equalized version. You can never go wrong with using an external equalized TEV, but there are two circumstances where you must use the external equalized version. One is being an AC application, AC or heat pump, and the other is whenever a refrigerant distributor is being used. Our distributors are designed to give an additional pressure drop through the nozzle orifice to create a higher velocity of the vapor-liquid mixture so that you get a nice homogeneous mix as it hits the dispersion cone and equally feeds the feeder tubes. So in the example, if you were using an internal equalized valve, then it wouldn't pick up that additional pressure drop. For R22, that nominal pressure drop would be about 35 pounds, and for a 410A, it would be about 45 pounds through the nozzle and the feeder tubes. Standard TEV would have a 2 pushrod system, and what you have here is their inlet pressure that's sitting on top of the pin, and the outlet pressure underneath the pin. So obviously your inlet pressure is going to be high pressure, is going to be over the higher than the low side pressure. So you're going to have a port imbalance, and that's the difference between the inlet and outlet pressures. So port imbalance will tend to open the valve. We can negate this opening force by using a balanced ported valve. In this case, right underneath the on the push rod itself, you can see an area that's been milled away. It's a little thinner. That surface area underneath that lip is the same surface area as the angle of the pin. So then you have high pressure pushing up underneath the lip as well as pushing down the pin, and it puts the valve in a balanced port position. And it has a better control for low load situations. It can throttle down to about 25% of rated capacity. And it also has the ability to control over a larger range of conditions. 3 factors affecting the normal TV capacity: the port size, the stroke, and the pin angle. If you change any one of those when we're designing valves, it's going to change the nominal capacity of the valve. And for us, for the basis for the nominal capacity, using 22 and 410A, you notice the parameters we use for nominal capacities is a evaporative temperature of 40 degrees, a liquid temperature of 100 degrees. For 22, we use a pressure drop across the port at 100 psi, and for 410A, we use 160. And these might be hard to see, but hopefully you can follow along. If not, they're actually straight out of the our bulletin 1010, which is our expansion bulletin. And this is from the capacity charts. Here's an example of the nominal capacity of an R22 valve for the ER series TEV. Notice the nominal capacity is 5 tons. It's circled up there. Using the previous chart, we know that a 40-degree evaporator, 100-degree liquid, and 100-pound pressure drop through the port, that the correction factors are both 1, so the actual capacity is still 5 tons. But if you change any of those parameters, the capacity will change, which the next few slides will show. Here we're using the same 5-ton nominal ER valve. The evap temperature is still 40 degrees, but we've lowered the liquid temperature to 80 degrees. So now the correction factor is 1.12. In other words, you're getting 12% more capacity. We let the pressure drop the same at 100 psi. So you multiply it out, that 5-ton valve is now 5.6 actual tons. So just by changing the temperature of the liquid, you've increased the capacity of the valve just a little over ½ ton. And here we changed just the pressure drop across the port from 100 to 150, and now the correction factor there is 1.22, so we've increased it by 22%. If you use the same multiplication of the correction factors, now we've got a 6.1 ton valve. And then if you just take it one step further, we change both the temperature of the liquid and the pressure across the port, multiply it all out, and now that's a 6.8-ton valve. So you can see just by changing the parameters that you're using, that your nominal capacity valve, the actual capacity can be either higher or lower, depending on the operation. So as the load, look at a balance ported, a balanced load here. If you notice the bulb is sensing 54 degrees. If you use your PT chart, that determines that the opening pressure that the valve or the bulb is formulating is 153.8 psig. You have 130.7 pounds for the equalizer pressure, and then you have 23.1 pounds for the spring pressure. So that you add those two closing factors together, it's 153.8. So you have 153.8 in the opening force and 153.8 in the closing. So it's a balanced position. You notice that point of complete vaporization, or the starve point, is right there at that last end before it heads out of the outlet evaporator. As the load changes in the evaporator, the pressures of point 1 and 2 are going to change, forcing the valve to either a more open position or a more closed position, depending on the conditions. As that load increases, now the starve point is backing deeper into your evaporator. So now you're going to start picking up more superheat. From the point that turns to vapor, you're going to add superheat from that point on. So now you're having more superheat coming out of the evaporator to the bulb. The bulb is going to sense it. Now it's 58 degrees versus 54. So that's going to give you an increase in opening force. It's now 164.9. Your vap pressure and your spring pressure in this case are staying the same. So now the valve is going to stroke itself open to a more open position, trying to get itself back to a balanced state. And then as the load decreases, now that point of vaporization or starve point has gone beyond that last bend and somewhere getting closer to the outlet of the evaporator, so it has less time to pick up superheat. So the bulb is going to pick up that lack of superheat or that decrease of superheat, and now it's only sensing 50 degrees. So using your PT chart, 50 degrees is going to be an opening force in the bulb of 143. Well, you have 153 in your closing force because your spring pressure and your vap pressure is still staying the same. So now the valve is going to stroke to a more closed position, trying to find itself in that balanced state. Now at the point of vaporization, or the starve point, goes beyond the bulb location, you're going to have 0 degrees of superheat. And in that scenario, you don't know exactly where that point of vaporization is going to be. And then, so you have a chance that you might be flooding back or slugging the compressor liquid because you don't know how far past that bulb, which is the control point, that the liquid turns into a vapor. When you talk about servicing the system of the TV, it frequently begins with the air handling unit and the TV itself. You want to make sure you take a good superheat reading and a good pressure reading.
And it's very important to take a superheat reading and understand the concept of superheat for anybody that doesn't.
Because, like I said earlier, that the valve only controls superheat. So if you call in asking for help for a valve for troubleshooting, that's one of the first things they're going to ask you is what's the superheat. And it's always easy to point the finger at the valve, one, because it's the least expensive of the key components that you're working on in the AC system, and two, because the operation of the TV is not very well understood. So you tend to point things out that you don't understand as being the culprit. But as you can see when we go through these slides, it's rare that the TV that's the problem, is something else in the system that the TV is either reacting to or it's causing the system to have the failure or the problems they're seeing. Let's look at some of the other components found in the refrigeration cycle and their functions. The liquid line joins the various high-side components, but its primary function is to supply a vapor-free liquid to the TV inlet. And by vapor-free liquid, we mean subcooled liquid. Vapor formation in the liquid line is a progressive thing. When the first few bubbles occur, they offer added resistance and an added pressure drop, which then it creates more vapor, which then creates more pressure drop. So vapor increases the pressure drop through the accessories, making it even harder to estimate how much total pressure drop you're losing. Pressure drop due to the flow friction can be minimized with proper line sizing and design. And one point to remember on line sizing, if in doubt, use the next size up. But in this case, make sure you follow Unico's line sizing suggestions to reduce the flow friction mentioned in point 1, because they do the work for you. Since refrigerant has weight to it, any kind of vertical lift will cause pressure drop. And so if you're taking this up to the attic, you're going to have 20 foot of lift at least. So approximately half a foot PSI per foot for most common refrigerants.
And that's a very important thing for everybody to remember, because the vast majority of our jobs, we have the Unico system up in the attic, we got the air handler, the condensing unit outside, so it's not uncommon to have 20, 25, as much as 50-foot height difference. So this is very important when it comes to charging the systems.
So in this case, we were showing a 20-foot lift, so that means we have 10 pounds of pressure loss through that vertical lift. So then the question becomes, to prevent the flash gas formation in the liquid line, you have to subcool the refrigerant below the condensing temperature, but how much subcooling do you need? This can easily be determined by a reasonably accurate estimate of liquid line pressure drops. This example on your screen is R22. The total pressure drop is 18 psi. You have 10 through your vertical lift, 4 through your flow friction for your line set, and then another 4 through your accessories, 2 for the catch-all and 2 for the solenoid. So your total pressure drop is 18 psi. So the condensing pressure at point A is 220 psi, which is a saturated temperature of 108. And because of those losses, you lost 18 psi. By the time it gets to the inlet of the TV, it's 202 pounds of pressure, which is equal to 102 degrees on the PT chart. So then it tells you that you need at least 6 degrees of subcooling from point A to point B to make sure you still have a full common liquid at that point. As we continue around the refrigeration cycle, we come to the evaporator and distributor if one's being used. Points 1, proper nozzle selection, the proper circuit diameters and equal lengths, and adequate surface, those are all done by Unico during their design of the system, so they shouldn't be an issue for you. But number 4, let me just say airflow, airflow, airflow.
I made him say that, by the way, guys.
I'll say it again, airflow. If you don't have the proper airflow across the coil, you'll not get the heat exchange needed for the system to run efficiently, and you'll not get the cooling you need. So Pete here will tell you how many CFMs Unico requires.
Minimum 200 CFM at all times. And remember, don't try to reinvent the wheel. We spent a lot of time, Craig Messmer spent a lot of time on R&D coming up with the right sizes for everything here.
This lack of airflow is one of the biggest issues that Unico sees in their troubleshooting on their tech support.
95% probably.
And then in point 5, if you suspect that the unit is hunting, or an easy check is to take a temperature reading at each of the outlets at the header. They should all be the same temperature. If you see one that's higher, then you probably have a problem with the distribution, so you might want to go back to number 1 and number 2 and a little more thoroughly, because they might be blocked. But the higher temperature is indicating that you do have some sort of distribution issue in those particular circuits. Condenser sizing and adequate surface area. You know, when you're matching up the system, you want to make sure that you don't go conserve on costs on this, because it's going to lead to higher operating costs if you go too small, greater compressor ratios, and reduce system life. And number 2, cold weather operations is especially important if the system is expected to be running year-round or late into the fall or start up again early in the spring. The TV can handle fluctuating head pressures, but if you go too extreme, then you're going to run into some hunting issues. And number 3, elimination of non-condensables, air. Non-condensables can add water and oxygen to your system, causing the formation of sludges, acids, rust, and copper plating, among other things. The only way to prevent their presence is to properly evacuate the system when it's first installed, and also to evacuate it during any subsequent service calls where you break into the system. If you break into the system, you need to make sure you evacuate again. And then number 4 is, once again, making sure you have essential to maintain reasonable head pressure for good system performance. Installation tips. You're talking about the bulb mounted on a horizontal free draining section of the suction line at the evaporator outlet. And the 2 things you want to look at there is the thermal contact and the location on the circumference of the pipe. The thermal contact, you want to mount it on a straight, clean section parallel to the suction line. You don't want to go beyond, like on a bend, where it's half the bulb is hanging into the ambient condition. You want to make sure it's touching the entire length of good, clean tubing, not across a fitting, and not with tape. You want to make sure you use the straps that are supplied in the valve box when you get it.
They come with the box. Don't throw it away.
And zip ties are also not recommended. So where it's located in their circumference. On the larger lines, typically 7/8 or larger, we want it the 4 o'clock position or the 8 o'clock position. You don't want to mount it at the bottom because that's where the oil return is coming back. Oil acts as a insulation, and you're not going to get a good temperature reading from through your bulb. And you also don't want to be bulb trapped. This piping doesn't actually give you any satisfactory bulb location, so you might actually have to repipe to get yourself a good spot. If you have to go on a vertical line, we always say horizontal, but if you have to go on a vertical line, the issue there is going to be when that oil does drop out, you don't know exactly where it's going to cling to the pipe, so you might have to find the sweet spot and just experiment with that bulb location. But in this case, you have to repipe to get this in a good spot. And here you trap the suction line, not the bulb. And this is better so the liquid and the oil can drain away from the bulb, and you get a good sense of what the temperature is in that line. External equalized valves. When you have an external equalizer, you have to connect it. You can't cap it. You can't make it an internal equalized valve by closing it off. Because earlier I said it's a drilled passageway for an internal. So you just can't make it internal by capping it off. And you also have to make sure that the equalizer line is free of any kind of crimps. Make sure it's not plugged with solder, no dirt and debris. Swirling TVs can be mounted in any direction and feed in any position. So the sky's the limit there.
We only really give you one place to put it in. We use check lap fittings. We don't braze these in like we did in the old days. So I want to say idiot-proof because it's amazing, Ron, what idiots can come up with. But we make it pretty simple. There's really very little room for error in this sort of thing.
But if you do find yourself with a valve that has to be soldered in, there's no need to disassemble it. Make sure you wrap it real good with a wet cloth. Direct the flame away from the body. Don't use an oversized tip. Don't put any excessive heat in a diaphragm, and keep the flame away from the bulb. And number 2, use dry nitrogen for reducing the atmosphere. If you happen to have the July issue of RSES Journal, there's an interesting article by Bob Henson of Harris Products Group on the importance of using nitrogen while brazing to prevent the formation of oxides during insulation. It has some good pictures of some pipes where they used nitrogen and where they didn't in the formation of the oxide scale. And today's using POE oil, that cleaning action of POE oil will clean those oxide scale from the tubing wall, and it's going to deposit in the strainers, the ports, or any other small passageways for pilot-operated components. And then finally, you want to test for leaks. Pressurize the system with dry nitrogen. If you need to, go ahead and supplement with refrigerant if necessary, and then test for leaks. Evacuate non-condensables and water from the system using a well-maintained vacuum pump. Always check with the compressor manufacturer, but most of them will tell you not to use their compressor as a vacuum pump. It's really not designed. The compressor valves are not designed to pull a vacuum. It's not always lubricated properly. Compressor oil could be contaminated that you're going to introduce to the system. And then the compressor motor itself requires cooled vapor across it to cool the motor. And so if you don't have any refrigerant in the system, obviously you're not getting that cooling you need.
And this is very important too when we get into the I-series with the inverter technology. You got to have you got to pump a deep vacuum. What did you recommend, Ron?
At least 500
microns.
And then it's also a triple evacuation system is always better. Break it with nitrogen and do it again. Break it with nitrogen and do it again. But if the job is properly installed, there's seldom a problem because it is a closed system. It's they shouldn't have any issues. But if the shooting services ever need it, first thing you want to do is listen to the complaint. And what's the biggest complaint you're going to get is probably I'm hot, or it's not working. It's not cooling the house, whatever the case may be. So you might have to ask some questions like how long it's been going on. Is this only during the heat of the day? Is it all day long? Has it been progressive? Did it just happen yesterday? And then you want to use your instruments and take a good measurements of your superheat and suction pressure. You don't want to guess. In this case, beer can, cold, you won't cut it. Take good measurements using reliable equipment. The relationship of the superheat and suction pressure is a good, nice, reliable guide for system analysis. So then make a good systematic analysis based on a complaint that the customer is telling you and the measurements you're taking. And the first reaction might be to change parts. And even though that's good for business, I appreciate that very much. it's not necessary, and it usually doesn't solve the problem. I've had many phone calls when I worked in tech support where the technician calls in saying he changed the TV, and then the new valve is doing the same thing as the old one. All he really did there is prove that the TV isn't the issue. Superheat and suction pressure readings can pinpoint the real problem.
So just checking to see if we had any questions. There's been a lot of information out here, and again, very interesting couple of slides coming up shortly on why we get valves returned.
4 basic scenarios you're going to have is the feed's not enough. In other words, you're not getting enough refrigerant to the system. So that's commonly referred to as starving the coil. Then it's going to feed too much is number 2, and that means you're having too much liquid getting to the coil, and now you're flooding it. Number 3 is feeds not enough, and then feeds too much, so now you get the hunting and cycling. And number 4 is flood back during startup only. And I'm not going to read all these causes to you, and you don't have to write them all down. They actually can be found in your Sportland PT card. So we're going to go to the first one, the feed's not enough. That's low suction pressure and high superheat. You took those readings, now you know I've got low suction and high superheat. I'm in a starved condition. And here are some of the issues that could be. And like I said, I'm not going to read them all, but the first one, moisture, dirt, wax, it pops right out at you. Okay, if the valve's sticking, it can't open and close, then it's going to have a problem. Could be the wrong element on the charge. It could be a dead element. If you have a dead element, you just take the bulb off the line and hold it in your hand, and the warmth of your hand should be enough to open the valve up, and that's the first indication if it's a dead element or not. Since that's your opening force, if you don't have any constituents in your bulb, then you have no opening force, and you're going to be in that low suction pressure, high superheat condition. Next one is feeds too much. You're going to have high suction pressure because you're not boiling off that refrigerant, and you're going to have low superheat because you're not boiling it off. There's not enough time for it to gain enough superheat. And that could be an oversized valve. It could be a seat leakage issue. But if you look down at number 7, there you go, moisture, dirt, wax. So it's blamed for a lot of stuff. And then next is hunting. We have a low suction pressure and low superheat. It's feeding too much, then not enough, feeding too much. It could be a low load situation where you're not having enough air. It could be dirty air filters. It could be poor air distribution, airflow again. Or it could be a poor refrigerant distribution issue. And that's where that having the wrong size nozzle, the wrong size tubes can indicate that you're having a hunting issue problem. So hunting and cycling, if you have a single compressor and evaporator, you're going to have a variation in both the suction pressure and the superheat. But if you have multiple evaporators and compressors, then you're going to have some superheat variation, but only a slight change in your pressure.
And almost all of ours are single-stage compressors today.
And then the next one would be flood back during startup. So that means when the system calls for cooling, the valve standing wide open is hot, you're going to have a chance for some liquid to get past. It's because the valve doesn't react fast enough in some cases because of some of the other issues like oversized valve or it could be an interrupted pump down system if you're using a pump down system. But it could be restricted or a plugged external equalizer as well. And then just to kind of back up a little bit with this hunting and cycling, if it's moderate hunting with no flood back, then you don't really need to do anything. Just try to find the best superheat where you don't flood back and you don't overheat. And then if you have severe hunting with flood back, then you're going to have to do something because you're sending liquid back to your compressor. And the specific cause is a little difficult to pinpoint, so you're going to have to do some experimenting. And I'd start off with bulb location. If the bulb is located in the airstream, you need to either relocate it or insulate the bulb so it's only sensing the true ambient, or it's not picking up ambient temperature, it's only picking up the suction line. Make sure it's not trapped. If so, repipe if you need to. And then the location, if it's somewhere near an elbow or some other kind of turbulent area, move it away from that area. If you're hunting and it might be a superheat setting, in air conditioning, try closing the valve 3 or 4 turns. If the hunting stops, then open the valve gradually and try to find that best setting. But if it still hunts, then it's probably an indication that the valve is too big to begin with. Choose a proper size, don't oversize. Sometimes a smaller valve is required for certain operating conditions, but then you got to make sure that that smaller valve is also still big enough to handle the maximum load.
Buy your valves from Unico.
There you go. Mechanical services. Here's
This is a great slide, guys. I really was impressed when I saw this. So, especially you guys on the wholesale side, I think you'll find this to be quite interesting, what they get back when they analyze the returns.
We get lots of valves back that just say they're defective. Defective doesn't necessarily mean that the valve is bad in this case, because a very small percentage of valves returned actually have a manufacturing defect. And these barrels are relative to the number of valves we get back and the actual cause of those valves being returned. Most of them we find in a small barrel with broken capillaries and some kind of physical abuse, hammered body type thing. The middle barrel, all the valves test out okay. It's either been misapplied or there's been an error in analysis by the technician. And then our biggest culprit for issues is the dirt, moisture, and corrosion in the valve.
And that goes back to proper charging and evacuation of the system.
Exactly. But most valves can be disassembled using some wrenches, and you can inspect the internal parts. What you're looking for is discoloration, solder, sludge, wax, any kind of corrosion. But remember, if you install a catch-all filter dryer head of every TV, that's your insurance against those acid, moisture, sludges that gets into your TV. Valve performance can never be restored or improved by physical force.
Don't take a hammer out.
Disassembly might uncover the true problem. And I know we all tap on one and it seems to open up and feed, so I figure if a little tap worked, a big tap ought to really make it work. And really all you're doing is distorting the internal parts of the valve can't operate properly. What you need to do is eliminate the problem. And this is a real-world situation where I took these pictures myself. These were OEM installed, not by Unico. This is from a big OEM for a produce cooler. But you notice the discoloration on the pin and carrier. You also notice some sludge on the pin itself. The biggest thing that jumps out at you is the rust on the springs. In this case, that the technician swore that the problem was that the valve was undersized. And I sized it for him. We went through the program, and I finally said, listen, it's not a sizing issue. You got something wrong with your valve. We took it apart, and this is what we found. So summing up, the TV plays a vital role in the system, but many system problems are not TV related. Sometimes the combined, the TV doesn't deserve all the credit for the system problems. It's a combined effect of many factors involved that tell the story. The elimination of one or more of these factors may allow the system to perform properly. It's very important that the system design, the component selection, installation, and proper adjustment of the controls be done initially when you first start the system up, so the system performs as it's actually designed to do.
Check your airflow.
I remember bulb and external equalizer locations can affect performance. We spend a lot of time talking about it, so make sure that when you go back and you look at these, that they're actually located in the right spots. The basis of any system diagnosis is superheat. It's the pulse of the system. And the very definition of superheat reminds you that you have to take a good suction pressure reading at the bulb as well as the actual temperature. And without a superheat value, any diagnosis that you come up with is haphazard at best. And like I said, if you call tech support, they're going to ask you what their superheat is. So be prepared. Don't tell us what we want to hear. Tell us what the actual superheat is.
To tell one of my people that's on the line right here says, I've never seen a gauge that says fine on it. They do have numbers on them.
But if service is necessary, remember most spoiling valves can be disassembled easily. And if you do take one apart, once you take the valve apart, whether you take off the element or you tear the valve apart for cleaning, if it's a non-adjustable valve, what you're going to run into is that you've just changed the factory setting when you put it back together. There's no way to regain that factory setting. So you need to get yourself a bottom cap assembly kit from your local wholesaler. And these two BBIs and CBBI are the two most common that Unico uses. So those parts get the KA4 and the KAY1132 are what you're going to need. And you're going to basically convert your non-adjustable valve to an adjustable valve. So when you get back together and you take your good superheat reading, you can now adjust it if you need to. Now, if you go to sportonline.com, you can download Bulletin 10-9, which is our theory, application, and selection bulletin, and also Bulletin 10-10, or 10-11, which is the installation, field service, and assembly bulletin. Those two bulletins are probably the most comprehensive bulletins you're going to find that talk about about TEVs. Like I said, you can go to Spoiler Online to get this, and while you're there, you can also look at our product selection program and any other kind of bulletins we have for any of our other products are on there as well. So this concludes the presentation I have. So if you have any questions,
remember, the person that asks the best question gets a 6-pack of beer, and here it is, 3:30 on a Friday afternoon. 6-pack of beer sounds pretty good to me. I will have to say, Ron, this is a great class you put on. This is just the tip of the iceberg for what they have at Sporlan. Ron does the Ron, what is your actual position with Sporlan?
I'm actually the St. Louis territory sales engineer. So I have all of the metropolitan St. Louis area. My territory has actually changed a little bit. I'm going a little further west towards Kansas City as well. So most of the state of Missouri at this point, and a little bit of the metropolitan Illinois side of St. Louis.
But Sporlan has many classes that you can take online. They do a lot of classes in front of people. You do. Just tell them a little bit about your training schedule that you guys do for wholesalers and contractors.
Exactly. Wholesale has their own training that they can get online, on Sporlan online. But for the contractors out there, we're always offering to have classes after hours, during hours, whenever they need, at local tech schools, at local wholesalers, and then basically any other condition. Whenever we get a chance to stand up in front of a group of people and talk about our products, we'll jump on it and we'll do it. So whatever area you happen to be in, check with your local wholesaler to find out who your local sales rep is, and then get a hold of him, and they'll be glad to help you with whatever training class you might have or whatever product line we make.
And again, Ron, his product is used on just about everybody's piece of equipment that's out there. You make all the way from little tiny expansion valves all the way up to big industrial, don't you?
Exactly. Everything from fractional tonnage capacities to over 100 tons.
Oh my God, that's a big valve right there for 100 tons. So let's see what we've got. Just bear with me a second here, see if I've got any questions out there. And again, I hope everything went through. It's always like talking on a radio. I have no idea what kind of reaction we have out there from people. Let's see, Lou DePrima has a question. Okay, we'll see Lou's question here. And can you read that?
Lou is saying he agrees on the 500 microns. And his question is what I've seen is not waiting to make sure it holds the 500. That's a good point, Lou. Thank you. Yeah, if you're going to pull it down to 500 microns, you want to make sure that it holds the 500 microns. That's part of of checking for leaks. If
right.
It doesn't hold the 500 microns, that means you have a leak somewhere and you need to go find it.
So we have any other questions? Again, a lot of the problems we do have more problems with TXVs than I thought, but again, most of the problems with TXVs go back to not charging the system properly. So, I'm going to say, Ron, it's not that you guys never have a problem with the valve, it's just that it's very rare that is the case. It's almost always something else that is causing the valve to misbehave.
And there's always a chance that one's going to get through, but with our quality practices that we have in the factory and the fact that we're well-trained factory workers that are doing the job, they've been doing it for a long time. We've been in this business for a number of years, 80 years actually now. We understand the role of the TV, and we also make sure that our quality parts, our parts are quality when they come out so that you have less issues. Lou's got another question about the sight glass, and I agree with him. He's always encouraged people to use the sight glass.
Yeah, I was going to ask you about the sight glass.
And it is another troubleshooting tool, and especially if you put the sight glass prior to the inlet of the TV, then you know you're getting a good common liquid to the TV. Otherwise, that is your window into the system. If you have it back by the compressor, and then you have a full common liquid there, but you have to go through a 20-foot lift and through the attic, it does not guarantee that you're going to get 100% liquid at the inlet of the TV. So having that sight glass at that location is the best way to go. So that way you're going to know if you're getting that common liquid. And it's also good for troubleshooting. So if you have a catch-all that's plugged up, it's going to start acting as a metering device in a sense and start letting off flash gas. And you're going to pick that up by having that sight glass at that location right before it goes into the inlet of the TV.
So again, one of the things that we just talked about earlier, remember, most of our jobs are going to be, there's going to be a considerable vertical lift on them. So it's very important in that case, Ron, that they check the superheat to make sure that they're not flashing. Is that correct?
Well, the superheat's going to tell you if how much or where that star point is in your evaporator. So subcooling is what you want to check for the vertical. If you want to make sure you have enough subcooling to ensure that you have a full column of liquid. Ted Patterson has a question as well. His question is, what's my opinion of refrigerant additives, for example, leak detection liquids?
Just like the one we saw, the one of my reps gave me today.
And I'll give you the answer that I gave Pete when we talked about that. Is that the only two things that are supposed to be in a system, in a refrigeration system or a heat, AC cycle, is refrigerant and oil. So anything other than that, in my opinion, is a contaminant. So that being said, I'm sure there's going to be lots of leak detection manufacturers out there that don't like that. But I don't have an opinion, quite honest, about the use of them. I will say this, that there are some out there, the dyes and things that are catch-all actually will filter out. So you're wasting your money putting it in because the catch-all is actually going to catch it.
Is the catch-all, that's not something that Unico supplies, that's something that the wholesaler supplies?
Local wholesalers, some manufacturers will supply them, but
with
in
their
this
outside
case,
condensing unit?
Exactly, with the outside condensing unit. But always, we always, not that I want to get into a catch-all contamination discussion, but we always say it's the core that counts. We use a solid core desiccant. It gives you the entire length of the core is their filtering surface, so you get better filtration. You've got the right amount of desiccants to make sure that you're removing all the waxes and the sludges. You're removing the acids and the moisture, which is what's calling it. Here we go. Bob's got a question of what is the best subcooling for systems when you're varying the lifts?
Yeah, that's a good question. Because again, we have you had kind of a rule of thumb on that, Ron, that it was so many psi per foot of lift.
Yeah, the half a psi per foot of lift.
Now, I think that was with 22. I don't know with 410A.
I'm not sure the numbers for 410A, but it's going to be relatively close to the same. It might be a little bit more, but how to make sure you're getting that? How do you make sure you're getting subcooling? In some cases, people install another heat exchanger so that the subcooled liquid then will go through this extra heat exchanger to reduce the temperature as well. Most of your residential AC units don't go to that extreme. The best way to make sure you're getting the subcooled liquid is to make sure you have clean filters. You've cleaned your condensing unit so that get the airflow you need to get that heat exchange that you're looking for. So you have the subcooled liquid. If you've got a dirty condensing unit, you're not going to get the subcooling you need.
And again, just to kind of sum up, Ron, the big three are you want to triple evacuate, you want to dry nitrogen charge, and you want to use a liquid line dryer.
Exactly. At startup.
That's the big three right there. So, and of course, airflow. So,
Airflow.
Hey, that's right. Ron knows nothing about Unico except airflow, and he'll do very well. So, any other questions that we've had come in, Ron?
I don't see any at the moment.
Again, if you have a question, now I'm going to kind of make another plug here for Sporlan and their activities that they have. Again, do you have a fairly complex class, as I understand it, Ron, for the counterman, for the people at the counter?
Yeah, for the wholesale counter, we have a chill skills training that goes through all of our various product lines, so that the person you're dealing with at the wholesale level is better informed about our products and can help you with a better decision making. And Ted Patterson just sent in another question as well. And his question is, how frequently should the bulb be removed from the suction line for cleaning after a number of years to make sure you're still getting good thermal contact? And I will admit, Ted, that I've never been asked that question.
Yeah, I think it would be there for till the end of time, pretty much.
That would be my first answer. I know I've never thought about having to remove it to make sure there's nothing in there.
I think that's question of the week, by the way.
So, but I have heard, I will say this, I have heard that in systems where there's excessive amounts of moisture, if it's a cold location, obviously below freezing, that it might form some ice or something. But I've never been asked that question, so I don't have a good answer.
Very, very good, very good. We have some of the best people out there in this business, and they come up with some questions that really make you think. So that's always a good sign. Again, if they want to find out more about Sporlan training, what's the next step for them, Ron? What's the next step for finding out more about Sporlan training?
The easiest thing would be to actually contact your local Sporlan sales representative. He can direct you to any classes that he might be performing locally for either tech schools or wholesalers. Another good source would be your wholesaler, especially if you go to the wholesaler and ask, hey, can you help present a class on whatever the subject matter you want, and then have that wholesale get a hold of the Sporlan representative. We do offer some training online, like right now we're mostly the wholesale counter guys training. We do have some training coming up in the future that's going to be on there for the contractors and technicians as well, and it'll be up and running here hopefully soon. Do
you have NATE or CEU classes that you have available?
There are lots of our classes that are actually NATE certified type classes, and depending on what region and what state, as far as the CEU points, Kentucky has different rules than Missouri, which has different rules.
Kentucky, Ohio, Alabama all have very strict CEU laws.
And then it's usually just a matter of getting the right person, through your RSES or ASHRAE to find out what those are and make sure that the instructor who's coming in meets the requirements.
Very good. Again, any other questions, guys? You know how it's going to be. You're going to think of something the minute after we conclude this, and if we do, just you want to give them your email address. You've all got mine, PPE@unicosystem.com. And Ron, give them your email too, if you wouldn't mind.
Yeah, no problem. My email address is rgbleckley@parker.com. So
Bleckley, Parker.
Yeah, exactly. Bleckley is BLECHLE. So rgbleckley@parker.com. And if you needed to talk to a tech support at Sporlan, the phone number there is area code 636-239-1111. You're going to get an actual operator, a real person, and then you just ask.
That doesn't happen too often, except when you call here in Unico.
And then you're going to ask for tech support, and they'll put you into the loop for the tech support. And if no one's on the phone that particular time, you're going to go straight to someone. If they're all busy, you'll be put in the loop, and the next available person will come up. And I tell you, Kevin and Steve and Justin all do a great job of answering questions. So they're happy to help you. Just give them a ring.
How about that for an idea, guys? You talk to a live human being that knows what they're talking about. Not too often. You're a much, much bigger company than we are, so pretty rare. So have anything else come up? Any other questions come up in the time? Guys, you've been a great audience on this. This is going to be stored on our website. It'll be on Unico University so that you can take this anytime that you like. And as they say, we really just scratched the surface for what all Sporlan has to do, what it can do for you. And again, I want to thank Ron for spending the time, giving up time to come in here and see us. And hope to see all of you again next month for our next Pints with Pete. Have a safe weekend, everybody, and enjoy the nice weather. Enjoy the polar vortex while it lasts. So thank you very much.